So here we are at an empty screen where we're going to start the Mount Rushmore app. And as I mentioned before, we're going to use a canvas to hold the image because a canvas, when we tap it, will provide us with the coordinates of where the tap occurred. So the canvas is down under Drawing and Animation. We're going to drag it in. And now I want to choose the image. I've already uploaded the Mount Rushmore image, and the dimensions of the image are 320 by 240. So if I choose the background image of the canvas to be that Mount Rushmore, it should automatically resize the canvas. But just to make sure, we can set the dimensions of it to 320 by 240, specifically in case we're on a different device or something else goes wrong. So I'm going to use 320 by 240 as the size of my canvas. We should see that update in the emulator. Let's reset our connection. And there we see our Mount Rushmore photo in the emulator. So we're going to be handling clicks on the canvas. And if I were to click over here, that would be transmitting the coordinate of my click to the screen. I'm going to switch over to my blocks editor and show you how we receive that. Under Canvas 1, there's canvas1.touched. And when you click that, it will give me the X and the Y, and if there's a sprite on there, like we had the mole mash, if there's a sprite on the canvas, it'll tell me which sprite was the one that was touched. But what I'm more interested in is the X and Y coordinate of the click. And what I want to know is that click in the area of George Washington? Well, we need to figure out a couple things. So first of all, we need to know the dimensions of George Washington's face, and we were representing it by a circle. So let's just guess and check here a little bit, and let's draw a circle on this canvas to see if we can come up with a circle that represents his face. Canvas 1 has some functions here. One is draw a circle, and I'm going to start. I'm just going to guess and say I'm going to go 40 pixels over and 30 pixels down, and I'm going to make a radius of my circle of 35. And now when I click this, it should draw a circle, and that should approximate George Washington's face. So I'm a little off mark on George Washington's face. I need to move my bubble down some, which is increasing the Y, and to the right a little, which is increasing the X. So I'll make that 45, moving the X to the right a little bit. Better make it 55. And the Y needs to come down almost half as much again, so let's make that 70. Perfect. I'll go with that. So we now have our X and Y and our radius. And now we need to know if there was a touch event that occurred there. So how do we know if it's within that black circle? We know it's within that circle if the distance between the center of the circle, which is 55 to 70, and the tap is less than or equal to the radius, which is 35. So all we need to do is the distance formula. But do you remember the distance formula? I'm old, so I don't remember the distance formula, but I can look it up. And there's one right there. Distance is the square root of x minus x squared plus y minus y squared. So we can work with that. Rather than putting those components right in here, because we're going to be doing the distance formula for both of the presidents whose faces are circles, why don't we create a procedure that will let us reuse the distance formula once we get it put in. So this top procedure is to do some kind of work, but it doesn't produce an answer. This bottom procedure does some kind of math or calculation, and it produces a result. And the distance formula, we need to produce the result, which is the distance. So drag that out. Looking at our formula, it says the biggest part is the square root. So I can for sure come into math and find square root. And now the next biggest part is a plus. So we're going to take the square root of the sum of two things. So we're going to go to math and get us a plus. And it's the sum of the squares of something on the left and the squares of something on the right. If I look under math, App Inventor does not have a square. It has square root, but it does not have square. So we could just times something by something else, but it looks like the distance formula, we're going to be timesing a difference, and that would be cumbersome. So why don't we just make a procedure to do square, just like we made a procedure to do something else. So we're going to drag out procedure, and it's going to have a result because you square something and you get a result. And we need to make the name of this like square. And so how do you square something? Well, you have some input that you're going to multiply. And we can use this mutator here to change the square method and say we're going to have one input, and we'll leave it as x. So notice dragging that in changed our method to take an x. And now it's just like our Canvas Touch, which has x, y, and touched sprite. We're adding values. You can add as many of these as you want, and they'll come around over here. But for squaring something, we just need the input, the single input. So we're going to square x. To square x, you just times x by itself. So math times, and then you hover over this x and get it. You hover over this x and get it again. So now we've made a procedure called square, which takes one value x, and it returns the product of x times x. If you want to get that stuff out of the way, you know you did it right, you're happy with it, you can collapse the block, and it goes up here into just one little block, so it's out of the way. So now we know how to square something. Back to our formula. We're going to square x2 minus x1. Well, what is this x and y thing? So we're going to be trying to find the distance. So let's name our procedure distance. And then we need to add some of these values. We're going to have 4 of them. So we're going to have x1, y1, x2, and y2. So now we have our inputs for this distance formula. Now we can talk about them. So we are going to take the difference of x2 minus x1. So difference of x2 minus x1 and the difference of y2 and y1. Now, did I do it right, or have I missed something? Looking back at our formula, the biggest component is the square root. On my formula, the biggest component is the square root. The next biggest component is the plus, and on mine, the next biggest component is the plus. On the formula, though, I'm supposed to square these differences, and I've forgotten to. So that one has to be squared, and that one has to be squared. But fortunately, I've made a square procedure. So to call that procedure, I go back to procedures, and then I drag out a to square. And I can drag it out again and square this other one. So now I put these back. And my formula says to find the distance between x1, y1, and x2, y2, I do this, and then send the result back as the result. So I've made my distance formula, and just like anything else, I can collapse it and park it over here. Now, what was the algorithm to figure out if our touch was in the circle? The algorithm is if the touched location is less than the radius, if the distance between the center of the circle and the touched location. So let's just do this. So we need an if then, and then we need a distance. If the distance is less than or equal to, so where do we get our less than or equal to? It's under math. Less than or equal to, and we need 35, because that's the radius of that circle. And the distance from the center of the circle, and the center, well, the distance from the touch to the center of the circle, which is 5570. So we want to know if the distance is less than or equal to 35, then we can do something. And what we want to do is to say George Washington. Well, to say George Washington, I need one of these text-to-speech thingies. It's called a widget. And then I can say text-to-speech, say George Washington. So let's check it out. If I click over here, over here, over here, I get nothing.
George Washington.
But when I click on George Washington,
George Washington,
the computer speaks the name. And outside that circle, nothing.
George
Inside
Washington.
that circle, I got what I want. Good stuff. Okay, so now all I would need to do Jefferson is to find the circle which represents Jefferson's face, and then figure out if the distance from the tap is less than the radius of that circle, is less than the distance from the point to the center of the circle. You get what I mean. You understand. I'm going to shut up and let you do it. Now, if I were working, say, for Abraham Lincoln, and I wanted to represent Abraham Lincoln as a rectangle rather than as a circle, then I would need to do a little bit different math. So let's talk about what it takes to draw a rectangle. We need to draw a line down, over, up, and back. There is, unfortunately, under a canvas, there is no draw a rectangle. We have draw a line, we have draw a point, and we have draw text, but there is no draw a rectangle. So, you know, we're learning these procedures. Let's talk about a procedure to draw a rectangle. Now, because a rectangle does not have an answer, a rectangle is sort of a list of things to do, then we're going to use the one that does not have an answer. So how would I draw a rectangle? I need some values. I need the coordinates of the top left point and the coordinates of the bottom right point, for instance. So I'm going to take two ordered pairs. So we have x top, y top, x bottom, y bottom. And then we could, so let's just draw, instead of drawing a rectangle, let's draw a diagonal line to see how this works. So on the canvas, I have the ability to draw a line. And let's just draw this from the XY pair from the top to the XY pair at the bottom. And I would expect this to draw a diagonal line like so on the thing that we tell it to. So we have draw a rectangle. We'll come back to that. But I want to use it when I touch the canvas. I want to draw a rectangle, and let's guess, since this is 320, I'm going to guess 280 as my x value, and 240, half of that would be 60. I already forgot what I said, but I think 60 is going to be my value for over here. 240, 100, no, 120. 120. So if this is 320, and I need to go about a third over 32, let's go 110. So I'm guessing that this is going to be about here, and then I have really no idea about this. How far over is this one? 300, we're going to say. And the Y, 240, let's call it 200. I'm just guessing here. Click it. Do I get a line? I do get a line. It needs to go over further, which means my x needs to be maybe 10 more pixels. And my y needs to go down not quite as far, so I'm going to do 110. And my my x and y for the bottom, it could come back a little bit, so maybe 290. And the y, 185. You know what? That's close enough for now, just for a demonstration. So this is the top left boundary of my rectangle at 220, 110. This is the bottom right boundary of my rectangle at 290, 185. And I essentially want to know, is the place where the user clicks horizontally between here and here? So is it between this x value, is it between this y value and this y value in the y direction, and between this x value and this x value in the x direction? So is our click between here in the x and between here in the y? So how can we tell? Well, it's going to be another one of those ifs, but it's going to be a complex if because we need an and. We need to know if it's between here and here and between here and here. But how do we know what between means? Well, we can make a procedure, as usual. So what's the procedure for between going to look like? If we want to know if some value, x, is between some beginning value, I'm going to call it a, and some ending value, I'm going to call it z. If x is between a and z. If x is between a and z. So how do we know if x is between a and z? Well, we're going to do it by using comparisons. Is a less than or equal to x? And that will cover half of it if a is less than or equal to x. But we also need to know that that x is less than or equal to z. So let's get us another comparison thing. We need to know that x, the point we're asking about, is less than or equal to z. And we want to know if both of these are the case, so we need to use a logic block, which is an and. Because and is like, I'll only let you pass the class if you make an A and you wash my car. So you have to do them both in order to pass. Not really, that's just a joke. So we're going to say if this and this, then we're going to say that x is between a and z. So if a is less than or equal to x, and x is less than or equal to z, then we're going to say that a is between, or x is between a and z. So now we've defined our between block, and we can collapse that up so it doesn't take up any space. Now we're trying to figure out if the point that was clicked, how do we find that? We get this x, and we get this y. This tells us our x's and y's. We want to know if x is between, if x is between a and z, and we want to know if y is between the other a and z. So we can get out another between. But that doesn't go there. Let me make a little room so we can inspect this. This says if the x coordinate that was clicked is between the left is between the left and right boundaries of the face, and if the Y coordinate that is clicked is between the top and bottom boundaries of the face, as long as those are both the case, then that click is inside and we should say the name Abraham Lincoln. So we can text to speech, we can speak Abraham Lincoln. And let's find out where we need to place this. We don't need to draw that rectangle anymore. We can delete that block. And then we can ask the question below. So now whenever we touch the canvas, we're going to find out, ooh, do we need to say George Washington? Ooh, do we need to say Abraham Lincoln? So my emulator crashed yet again. It crashes a lot when I'm recording the screen, so that's what's going on with that. So I'll get my emulator open back up, and then we'll check it out. So if I click here, I should get George Washington.
George Washington.
If I click here, I should get Abraham Lincoln.
Abraham Lincoln.
I promise it works. It works on my tablet. It's the screen recording software fighting with the emulator. It does work. So let's open this up and see if we can review what these blocks do and what they're for and how they work. So I made a couple procedures just to help us. One of the procedures is to square. I'm going to expand that back out. We said that to square would be an input, which I called x. And we just used the times to multiply x by x. And that was simple. And the way that we made a benefit of that was to, we used it in the distance formula, didn't we? So distance is up here. Let's expand that block. And we said that to find the distance between 2 points, we needed to take the square root of the sum of the squares of the difference of the x's and the difference of the y's. And we used our square procedure, or a square function down here, to make this a little bit easier to see and to make it look a lot more like the formula from whatever web page we stole it from. We can add as many of these inputs as we want using this mutator, this set of gears, and we can make a procedure or a function that takes any number of inputs. And if you don't want to have that all waiting on you, you can collapse it just like that. And we looked at between. In between, we looked at and lets us know that this and this have to be true. So we want to know if it's between if this is the case and that is the case. And so this should look a lot like you saw it in geometry or in algebra. Collapse these blocks up so they don't take up as much room. And now that we know how to find the distance, we know how to square things, and we know how to find whether a number is between another number. And that simplified life over here a little bit. Now I can clean this up even more by making a procedure to tell if something is a president. And so I could say if, and then call the procedure to find out if this is Abraham Lincoln, or call the procedure to find out if it's George Washington. But what if we accidentally had defined a circle and a rectangle that overlapped? And the way this works is it checks to see if this is the case, then do this. And with this snap below it, it could conceivably try to say the names of both presidents. So I'm going to talk about an else part. I can modify this if by adding an else part right in there, just like the way we added components to our procedures. And now I can say else if. In this way, the else part only happens if the then part does not happen. So we check the question, is this the case? And if it is the case, then we do this. Else, we do that. And because this is an else if, there's actually a special version of else called else if. And we can plug this in and use one fewer block because we don't have to have an else and then an if. So I'm just going to drag these parts over there, and we can get rid of that one block. Good stuff. So now, this asks the question, should I say George Washington? And if I should, then I say George Washington. Else, I ask the question, should I say Abraham Lincoln? And if I should, then I say Abraham Lincoln. And this is all one big block. And you can add as many of these else-if components to this as you want. And if you're doing Mount Rushmore or something with 4 options, then you're going to have more else-ifs stacked on down here at the bottom, like so. Now, I don't have that many right now in this demonstration, so I'm going to take those back out, and I'll show you. You just peel them off the bottom like so. And there we have it. So this is a really basic Mount Rushmore app that only knows 2 presidents. You can add 2 more presidents in if you're doing a different image for a different class or for a different subject, that you have different areas. This shows you how you can determine if a click occurs within a circle on a canvas and if it occurred within a rectangle on a canvas. And I found the coordinates here, the center of the point and the radius, just by guessing and checking. And I found the x and y coordinates for the different corners of this thing also by guessing and